All right, this is lesson 5.8, day 2. So this is the second part of our rational zero theorem. So the first part we learned yesterday, which was finding all the possible rational roots. So on your assignment, you've already done that, but we're going to go ahead and take a look at that step for this first example. So first, coming up with that list, then we're going to use our graphing calculator, either the table or the graph, to find actual roots. And then we are going to use the rational roots to find the factors by dividing it synthetically. So let's go ahead and look at this first example. So we have x squared plus 5x plus 4. So our possible rational roots, PRR is what that represents. Our P is 4, which is going to get us plus or minus 1, 2, and 4 as factors. Our Q is 1, which is going to get us plus or minus 1. And then our possible rational roots would be P over Q. So that's going to be 1, 2, and 4, both plus or minus. So what we're going to do is look at our graph. So type it into the y equals, and we're going to either hit the graph button or hit the second graph button to get the table. And you can either find them right here where they're touching. So at 1 or 2, 3, at 4, so 1 or 4, or you can look in your, negative 1 or negative 4. You can look in your table and see them, excuse all the emails, and we have 1 there and 1 there. Look, negative 4 and negative 1. So from the calculator, so we get x equals negative 1, and that's from the calculator. So it's x plus 1 as a factor. So what we're going to do is step 3, we're going to use this root to divide the polynomial using synthetic division. So in the box, since we have negative 1 as our R value, we then put the coefficients up here, 1, 5, and 4. Goodness. And then we are going to bring down the first number and just use that synthetic division. Multiply, add, multiply, add. Since it's a factor, it should give you that remainder of 0. So what we have left is x minus 4. So our final answer, our factors, are x plus 1 and x minus 4. So that means that our roots, or zeros, are x equals negative 1 and x equals 4. So that's all we're doing. And you've already done this step 1 from the previous day. So we're just basically doing steps 2 through 4 for today. So we're going to take a look at the first 2 examples, and then we're going to do some in class. So we're just going to kind of fly through this day 1 stuff because you have done this on the previous day. So P is negative 12, or just 12, because we know we do plus and minus, and Q is 2. So factors of 12 would be 1, 2, 3, 4, 6, and 12, and the factors of 2 are 1 and 2. So all of our possible rational roots right down here, we're going to put our P's over our Q's. So all these numbers over 1, and then all these numbers over 2, and make sure we don't repeat any. So we've got 1, we have 1/2, we have 2, we have 3, we have 3/2, we have 4, we have 6, and we have 12. And all the rest end up repeating. So let's take a look at the new steps. And we are going to go to our calculator first. So from the calculator, we're going to find a root. So let's jump over to our calculator here, and we're going to go to the y equals button, and then we are going to type in our function here. So we're going to type in 2, then x, then to the third, then make sure to arrow over so it gets out of that exponent, plus 7x squared, and then arrow over, and then minus 7x minus 12. Okay, so again, you can either hit the graph button and look for it, or you can hit the second and hit the graph for the table. And then you can scroll until you find, oh, there's one, right here at negative 1, there is a 0. And if you look at your graph, there's one at -1 and -4 as well. But let's just go ahead and, well, we'll use that -4 one. So x equals -4, which means that x plus 4 is a factor. So you can either add it over here or just wait until the end. Just don't forget that one is a factor as well. So our next step is to use synthetic division. We're going to use -4 in the box using our coefficients 2, 7, -7, and -12. We're going to divide out that factor. So again, we know it's a factor, so it should get us a remainder of 0, no remainder. Yep. So what we have left is a 2x squared minus 1x minus 3. So our next step is to factor this, and we're going to factor it the long method because there's a number here. So factors of -6 that add to get -1. So that would be -3 and 2. So it's 2x squared minus 3x plus 2x minus 3. So I kept the first term, kept the last term, replaced the middle with my two factors. So grouping, I can pull out an x. Over here, I can't pull anything out, so I hold that front place with a 1. So now I've got my factors, x and 1, and a 2x minus 3. And then I also have one up here that I need to add in. So over here, we're going to write our answers. So we have a 2x minus 3. We have an x plus 1. And then we have our one that we pulled out and we found from the graph, the x plus 4. We also have to write that. So solving, setting each of these equal to 0, I'd get 3 halves. I would get -1 and -4. Those are my roots. So we're going to do one more together, and then we'll finish up and do some more in class on block day. So P is right here, 3. Q is up front there, 2. Factors of 3 are 1 and 3. Factors of 2, 1 and 2. So possible rational roots would be 1, 1/2, plus or minus for all of these, 3 and 3/2. And make sure again that they're plus minus, or that you know that. So going to the calculator, I'm just going to go ahead and tell you, again, you would type it into the y equals, look for when y is 0, but I'll just tell you for this one, from the calculator, we get -1 as a factor. So using that factor that we get from the calculator, we're going to synthetically divide that out and then factor what's left. So -6, oops, nope, that's -2. See, that's what happens when you go too fast. Sometimes you just gotta slow down. And then 0 for the remainder. So it's a 2x squared minus 7x plus 3 that we want to factor. So factors of 6 that add to get -7, and we're going to group. So -6x minus x plus 3. So pulling out a 2x for that first set, we get an x minus 3. Over here, pulling out a -1. So that it matches, and we get 2x minus 1 and x minus 3. So we're going to put those over here as our factors, and then we also can't forget the one that we originally took out, which has, if we put it back in, x plus 1. So our answers are -1, add 1, divide by 2, 1/2, and then add 3, so 3. There's our 3 roots.